My name is Carl Quinn. I'm going to talk today about the Netflix open source cloud, what would you call it, package of projects? Platform, cloud platform, yeah, that's what it's called. I was, up until a couple months ago, manager of the engineering or cloud tools team at Netflix. We did a number of the projects and tools and things that I will talk about today. I've since moved on to a company called Riot Games. We have a game called League of Legends, which is one of the most popular games in the world right now, all over the world, distributed online, real-time multiplayer game. And we're kind of in, our growth is so big, and we're kind of going through the same growth pains that Netflix went through, 2 or 3 years ago. So we're also looking at the cloud as a solution for a lot of our back-end stuff, which is written in Java. So a lot of the same tooling and the same solutions that Netflix came across are very exciting. It's part of one of the reasons that they pulled me over as, like, can you do what you did at Netflix for us, right? So I'm doing that. And in a lot of ways, this will help, I think, prove how reusable this Netflix code is if another company can build on top of it. So I've broken this talk up into some sections where I'll first give you an overview of the projects, sort of in how you can find them and how they're organized, and then break down into talk about tools and infrastructure parts, and then sort of the platform and libraries and connection Java kind of related stuff. So the first bit, all of the projects for Netflix open source are on GitHub, and they're under, so you can just go to the URL up there, netflix.github.com, and there's a whole big pretty page full of different project names. And they're currently just a big pile of names, and they're all mixed up, so you have to kind of sit and read about each one and figure out what they do, but that's kind of fun to explore. Some of them are tools, some of them are libraries, some of them are apps, services that you run, some of them are samples, like Hello World kind of samples. Other ones are like the Cloud Prize, so that's exciting if you're interested in contributing something back to the open source project and earning $10,000 prize money per category. That's one of the things there. But today I'm going to focus on a couple of different areas, and so a bunch of these that are related to some things like Cassandra and Zookeeper are very interesting, but they really are kind of an entire talk on their own. So the ones that are lit are the ones I'll be talking about today. As you can see, yeah, they're all kind of over the place. All of them that result in libraries end up on Maven Central. So if you're a Java developer, you're building with Maven or Gradle, you can reference them from Maven Central, and they'll be up there. Other ones that end up as Wars projects, I think, what do you guys are putting them up on Box now, or no, Bintray. Okay, yeah, so everything that's a binary that's not really a library that would be Maven oriented will be on Bintray as well. But each of the projects will tell you about how to go find the bits that you might want to get and play with. So the master plan, which I'm sort of have insider knowledge about the Netflix master plan for this whole thing, is they really do want to create an entire cloud platform that any company can use and pick up these parts and mix and match and build a cloud infrastructure, a complete cloud application on top of this. And there are already some of the examples that they have are kind of mini apps that are end-to-end, front end, middle tier, data storage, Cassandra or DynamoDB. You can build an entire app, service-oriented, SOA type application on top of this stack. And all this code came from code that Netflix built to run their own infrastructure. A lot of it was, it was all taken from stuff that was in production, good quality, lots of tests, but there's still a lot of challenges to taking something that's working fine in your enterprise and turning it into something that's open source. I mean, a lot of times you end up with code that is tangled with other code that's very specific to your own specific case. So that has to be disentangled. A lot of times dependencies have to be flipped around and code has to be refactored. Any assumptions that you've hard-coded stuff because our URLs are like this, or we've got these service names like this. Well, okay, you have to make that pluggable or configurable, something. So all that work has to have been done. And in some cases, they just looked at the way they did something and said, well, we wrote this, it evolved so much now it's really ugly and I'm embarrassed. I don't want anybody to see my open source code. So I'm going to just rewrite it. And so a number of the projects were really rewrites to perform the same function but with cleaner code, or maybe built on top of newer dependency injection frameworks or something where they could make it start from a cleaner base. And one saying that I don't know who came up with it. Maybe it was Ruslan, the whole bit, or maybe it was Adrian Cockcroft. It says, the code is good enough for production, but not yet good enough for GitHub. And so that's kind of one of the things you want to make sure that this is a lot of people, kind of your resume lives on GitHub if you're an open source contributor. That's really your portfolio. So you want to make sure, and the people at Netflix and anybody else contributing to these projects want to make sure it's good quality. That's going to reflect on them. Okay, so the next section I'll talk about a little bit about the projects that are related to kind of the structure or infrastructure of the clouds as you build it. So one of the things that Netflix does on top of AWS that's kind of unique is that they build and define kind of this platform structure on top of auto-scaling groups. So if you're familiar with Amazon AWS, they have the notion of an auto-scaling group. They don't always get as much attention as I think they should. A lot of people look at them and say, I'm not going to auto-scale my applications. I only need 5 machines, maybe 6. But they also provide something that's useful, even if you're not going to auto-scale. You can create an auto-scaling group and just say, I want 6, done, and you never change it. But what you've done is you've created an organizational unit that says these machines are all doing the same thing. They have a well-defined launch configuration that says that they're launched from the same AMI and they have the same user data, and so they kind of get associated together. And so Netflix builds on top of that by using auto-scaling groups and pairs or triples of auto-scaling groups together as a logical cluster. And in order to do that, they apply, so they want to really get in and modify anything with AWS, and they wanted the source of truth to be inside of AWS itself. So they created a very simple store to table in SimpleDB, I think, but moving to Dynamo, that uses a very small library and naming conventions. So you define an application. Let's say that it really represents a service in your service-oriented tiers. Let's say I've got a middle tier that is the search engine, right, or query engine, and that would be the name of the application. And when I deploy clusters of that application, I can deploy those into different stacks, but I can tell what the cluster is about because it is associated with that application. And there's a naming pattern that it uses to kind of parse apart the auto-scaling groups. And so that way you can have some additional structure and traceability throughout your machines and groups and clusters and applications, because more metadata can be included at the application level. Now, one of the things that's also unique about how Netflix builds its cloud is a lot of the assembly of the machines, almost all of the assembly of the machines, in fact, getting the binary bits onto a machine is done at build time. So if you really think about things you might do when you bring up a machine in a data center and you've got it up and you do the apt-get or the yum install and you're putting stuff in there and then you're adding packages and configuring things, a lot of that is like, that sounds like a build process to me. Just like you're building your Java code and you're building your WAR file, why don't you just keep going all the way to the point where you've built your machine, right? And then that's a deployable artifact. So that's exactly what Netflix does, and they released a couple months ago a tool called Aminator, which is really a very clever, but not even a huge amount of code, but nicely done Python toolkit that allows you to create AMIs. And also, these work with Eucalyptus. So the same things you can use to create EMIs in the Eucalyptus world. And so what Aminator does, the idea is you're going to treat this like a part of your build system. So Aminator will run on any machine that's on EC2 itself. So it could be on a Jenkins slave. It's a command line tool. You just call it from a Jenkins build job if you want, or you can just shell in and run it, just a Python command line tool. But it'll take, you identify to it a base image to start with, which could be, okay, public Ubuntu or public Amazon, Linux. I want to take that AMI, mount that as a volume, as an EBS volume on the machine, and then maybe run yum install or run chef solo or one of these tools to say, take a bunch of packages and put them onto that image, right? We haven't even launched the machine, it's just a disk image at that point. Then snapshot it, register it as an AMI, give it a description that you've given on the command line, And boom, now you have a whole new machine defined that's based upon, a well-defined starting point plus a description of what you wanted to put on it. Maybe packages from your build repo or cookbooks from your chef repository that you've put on there. So you have traceability from both, the machine, the base foundational image, plus everything else you've put onto it. And now you have an image that's identified, it's immutable, and it's just like another build artifact where you can then test it and be sure that that image is exactly what you want, and it's reproducible. Whenever you launch things from that image, you will get the same bits, right, the same version. And the cool thing about it is a lot of people say, well, that just takes so long. We can't bake a new image every time we want to change the version of a library we put on our server. But the only thing only takes 3 or 4 minutes to bake an image. It's just part of your continuous integration process that you just make that one more step in there. So I think that's really powerful. And in this flow here, you can see we've just made a new version of an AMI. And back when I mentioned clusters earlier, let's see, we were running our application and we had version 1 running. It was running in one auto-scaling group. We've just baked a new version. We push it out. We've run some tests on it, of course, in our continuous integration system. And now we've pushed out a new auto-scaling group for that application or that service in the cluster. And with Asgard, we'll be able to switch around and move traffic to the new one or move traffic back to the old one. The two can live in parallel for a little while until you're ready to completely switch traffic over. So you have a lot of control this way about how you want to scale up or warm up machines or scale down or manage that, or having the old ones around in case for failover. A lot of flexibility there. Now I'll talk a little bit about Asgard. So Asgard is the tool. It's written in Grails. It's also open source, very easy to set up and install and run and play around with. This is probably one of the first things, if you want to play with stuff and actually run something, this is fun to bring up in your cloud account and just start poking around with it, because it'll let you see stuff organized in ways that you wouldn't be able to see easily from the Amazon console. So here's a sample page from it. So we're just looking at auto-scaling groups. This screenshot's probably from somewhere in Netflix's test account. But it will also show you the associations that I mentioned earlier between applications and clusters, instances. You can drill around everything that's a kind of a name or an identity of another object that you see on any of these pages in Asgard, like on a list page or a details page. They are all links so that you can really easily traverse and click around and figure out how things go together. Really it helps, I think, learnability of what are all these things and how they relate to each other in AWS. It's really quite powerful. Even if you're not going to use this model, it's a nice tool to bring up and use just as some visibility into your cloud. And also, so Asgard, again, so I should mention, most of these tools do sort of rely on Amazon AWS APIs in this structure section of my talk, but they also work with Eucalyptus, and especially, so Eucalyptus 3.3 is coming out this quarter. It's in, I don't know which milestone it is now, sort of in beta right now. And the Eucalyptus guys will be shipping a set of the tools that are already pre-packaged with plugins necessary to make them work a little better in the Eucalyptus environment. So they're using a lot of these tools to sort of test their compatibility with AWS. So that, I think, is pretty exciting. If you want to build your own hybrid cloud, Eucalyptus is a nice solution there. So Edda is another tool, which is a service that runs, it's purely RESTful, has no GUI at all. Its job is to just scan and look at the cloud in your particular account or multiple accounts and kind of keep track of what's going on. So you can either run it just as an in-memory only, where it will just provide you a query service to tell you who's out there right now, what objects are there. It allows you to sort of reference things indirectly. Like you can ask it, what machine is at this IP address? And it sort of can do then a reverse lookup and tell you what went on. You can also attach storage to it, and it's currently using Mongo for its back end. And then it records the history of things, which is where it becomes really interesting. So for example, you might have some event that you're trying to track down some problem that happened on your machine yesterday at 4 o'clock for 20 minutes. I had a DOS, a storm of requests that was crazy, and I don't know where they came from. And you can go through here and figure out, okay, these 5 IP addresses were hammering my machine. What are they? oh, they were somebody brought up. You can do some queries, figure out, oh, that was 5 instances of somebody's test cluster that they brought up with a bunch of bugs in it, and they hammered my machine. So you can kind of reverse look at, history of things that happened. Or like there's a guy at Riot on my team now who's building a front end for it so that he can do security audit reports. He wants to know the history of everything and what changed and who made the changes or how they got changed, at what time, what they were done for. And just so that nothing funny happens and people start twiddling with things that he doesn't know about. So it's a great tool for that. The query language that it supports is really powerful. The monkeys are great. So back up here. So the monkeys, the SimianArmy, there's a number of the monkeys, like the chaos monkey, which is one of the most famous monkeys. The janitor monkey, I think, is probably the most useful one for people that are just getting started in Amazon. It can go through and track down objects that you've created that you may not be using anymore and give you reports and optionally clean stuff up automatically. You can give it rules about retention and things like that. So if you end up creating lots and lots of EBS snapshots that you're not using, or AMIs with the bakery, you're making a lot of AMIs in your continuous build process, and half of them or more you're not even going to use, but that's fine. The monkey can clean them up. And the chaos monkey, as you might already know, creates chaos. But the hardest part and the most useful part of the monkey itself is that he can be told how much chaos to create and where to create it and where not to create it. Leave these apps alone or leave these clusters alone because, well, we're not ready for chaos yet over here. But once you sort of embrace the chaos of the cloud, that will help ensure that your applications are tolerant to failures at the hardware level. Like an instance can go down and your cluster keeps going. That's a good thing to know. And the conformity monkey is the newest monkey that just came out. And he's really about checking to make sure you're following certain rules, sort of guidelines, best practices about how to organize your systems. And those rules are extensible, so you can plug those in. And he'll at the end generate reports and send mail to the owners of the applications. So you can look for any kind of anomalies that come up and maybe how you've deployed. You've done something funny, and he'll give you a report on that. There is a dashboard that Netflix has, and I'm not sure what are the plans. I think there's plans on open sourcing this part of it. I don't know what their schedule is, so I won't quiz the Netflix guys here. But they have a dashboard that looks like this that they use to look at sort of the state of the monkeys. What's the current thinking about what's going to be deleted? In this case, this is the janitor monkey's page. That's sort of his dashboard of what he's going to clean up. So hopefully that will get open source, maybe integrated into Asgard. Joe's nodding. It's on his backlog somewhere.
That's the current.
Yeah, that's the current plan. But if somebody else wanted to contribute to that, right? It's really just a section of pages in Asgard that are going to be talking to the monkeys, which are our service. So it's probably a cloud prize worthy chunk of code if somebody wants to do that. There's another tool, which is a command line tool. This is in my slides. It's also not yet out. It's on GitHub. There's a lot of Netflix specific bits in it, but it is kind of a cool client, and I worked on it, so I'm kind of proud of it. But it's a command line tool that is really just a REST client. It's all groovy, sort of a DSL mostly, but it just allows you to control any kind of the REST services, which most all the infrastructure for the Netflix cloud and a number of other tools like Jenkins and Jira. Something you might want to do as part of a continuous delivery deployment system. This kind of allows you to orchestrate it from either a workstation or from a Jenkins job. In this case, we're showing you how you can create a client to talk to Asgard, find a cluster object with a given naming pattern, and do another push. So we're going to push a new autoscaling group with a new AMI and wait for it to complete. So all the work is being done on Asgard in this case. We're just talking to it and telling it to start something you would just sort of replacing you from going and clicking on the web pages and doing all that by hand. So this kind of came from code that release engineers were using at Netflix, and they were doing it in Python or Shell or different things, and so we took all of their knowledge and put it into this. So hopefully we'll be able to produce a version of this that's useful to people outside of Netflix. So it should be coming in a while. Okay, so back here. So now we'll move on over to the connection side of things. So in this section, I'll talk a bit about how you would actually write your Java apps so that they work in this sort of cloud environment. Really, a lot of it is about breaking your application down into small sort of mini services, microservices, sometimes people call them, but really embracing the service-oriented architecture model. And one of the first things that is different in this model is that, so Amazon has load balancers. So at the top, you see those little guys coming in from the edge. Those are ELBs. Traffic comes in there. So if you have part of your service is just on the edge, you're going to be able to leverage Amazon's load balancers for getting traffic from the outside world. But once you're inside your service architecture and you've got all these different pieces, there really isn't a good solution from Amazon directly that's like a middle tier load balancer. They have a few now. You can have private load balancers, but they weren't there initially when Netflix built Discovery or Eureka. And now that they have it and it's really solid, you kind of look at some of the other approaches and say, well, this is actually really very nice. And so I don't think there's any plans on abandoning this. This is a really nice way of doing things. And so what you have as Eureka is a service that is just in-memory storage of other services that are registering and saying, I am here. So it's a way to discover what other machines are there. Service providers register their logical name, where they live, what are their health check URLs, and they heartbeat into this server. And it's storing all of its state in memory. Now then there's failovers that could be cross-zone failovers or just hot backups, standby backups that are in memory synchronizing to each other. So it is very stable and reliable. But it's also very fast and very simple. If a node goes down, that has track of everything. We can auto scale and bring up a new node to replace it, and it will sync itself up to the other node and be up and running again in a couple of minutes. But coming back first, when you bring up your application, so in the world where you've baked an AMI, let's say, and we've got this application. So I've baked my AMI, application foo, version X. This is really designed to be or intended to be launched in different places. I can launch it in a stack over here, I can launch it in prod, I can launch it in test, I can launch it in a debug development cluster. So when that application comes up, it kind of needs to know what it's intended for at this point in time. What's my environment, what are my settings, and maybe you do want to tweak things at runtime. Maybe I want to be able to turn on an experimental feature at runtime, have live traffic go to it, turn it off again later on. So what Netflix did, instead of trying to do that sort of dynamically with a service like Chef, where you're integrating that with building the machine, configuring the applications, doing the discovery, they said, well, let's build another service, right? So we're good at building services. We've built this whole service-oriented architecture. We know how to do REST. Let's just do another one for this. So Archaius is a project which provides Java-side client library for dynamic properties. So it leverages annotations in Java, which are really nice to use. You can have property files which sit as part of your build artifacts, so they're in your WAR property files. Plus, then it can layer in dynamic settings, changes, overrides that come in from some kind of storage. So the version of Archaius that's on GitHub right now, the client talks directly to Dynamo and does database queries, which is totally great for doing stuff and getting out of the box and running a small cluster. But when you start to scale up, the traffic to Dynamo is going to be really big. So Netflix internally has a service that sits in front of the database and serves the queries back to all the clients. And also we've done one at Riot. So we have that, and I think, so Jerome at Riot, who used to be at Netflix, wrote it, and he's working with the Netflix guys, and they're going to kind of converge those and put that together. So one way or the other, there will be available this Archaius server that's there. It accesses the front end, so it reads and writes to Dynamo with a REST API, and then all of the dozens or hundreds or thousands of machines that need to query about their dynamic properties will hit the service directly instead of going to the database. Quite a bit more efficient. And then I think. Let me double check my slide. No, okay, wait, that's it, okay. So back to Eureka again. So now I mentioned that all the services have registered with Eureka, so we know where they all are. We know what their IP addresses are. We know how healthy they are, or if any of them have been taken out of service. And if you have a client that needs to talk to a service, there's a Eureka client library that you can integrate into your application. And on top of that, there's another library called Ribbon, which can actually do the RPC for you. And what Eureka client does is it will talk to Eureka, pull down the whole chunk of basically a table of all the other guys that are out there, and then serve that as a library internally for any RPCs that you want to do. Like if I need to talk to, application X that's down below me, downstream below me, I say I need to talk to X in stack A, and you'll get back out of that query a list of maybe, okay, there's 40 machines there. How do we want to talk to them? How do we want to load balance through them? Do we want a round robin through those, or do we want it sticky, or do we want some kind of weighted? So Ribbon and Eureka Client together will provide you with that kind of service. So you really can just use it right out of the box and start talking to the downstream guys, and you'll automatically connect to the correct set of them. A little bit hard to read. What we got there? Oh, yeah, okay. There's a lot of different libraries here. On top of that, as a client, you might also have to deal with issues of downstream services being not always reliable. So if you're building something that's close to the edge of your application in your architecture, you may end up with a lot of downstream dependencies. Some of those may be unstable, or not necessarily unstable, but may not be able to always meet their SLAs. Things may get overloaded. You need to be very dynamic, and you want your service to be very defensive about how it replies and responds to its SLAs, right? So if you need to be up 99.9% of the time, and you rely on 100 services behind you that are also only up 99.9% of the time, it's all going to add up, and the failures are going to accumulate, right? So you'll never be able to meet your SLA if you're always relying on those other guys directly. So what Hystrix does is it allows you to have effectively a circuit breaker type setup, so that each point where you're talking to somebody downstream, you can say, well, if this guy doesn't meet the SLA that we've set and we've all agreed upon, he's starting to get overloaded, we'll switch off for a brief period of time and go to a fallback. So if I need to find out personalized recommendations or personalized ratings for my movie page that's going to show all of the movies for this customer, for this member, and that service is hammered and is not getting back to me, then instead of me sitting there waiting for it, I'm going to just circuit break over and just start giving the user generic ratings that are global ratings from another much less loaded service. Or I'll have some pre-cached values which are reasonable for now. So you get sort of this degraded service that fallback, and that's handled by Hystrix. A number of other libraries which are really handy. Blitz4j is a lock-free logging library, which allows you to do standard log4j logging that is really fast and doesn't have any locking in it. So you can have that integrated into code that is doing high performance stuff, and the logging won't be creating Heisenbugs for you and locking and slowing down things, right? You're just pushing stuff out very efficiently, very fast. So that's handy to have. If you're logging lots of things, and like Netflix does, logging and log rotating out to S3, lots of data that you can then look over later on and crunch over later on. Servo is a very useful library which sort of works with Java annotations again. It lets you annotate things that you want to be monitored, sort of metrics and behavior of things that are going on in your application. You can annotate with Servo. It exposes all those values, those metrics through JMX, and then they can be pushed out to other services. So the version that's in the open source project can push all the metrics to CloudWatch. Internally, Netflix has a monitoring system called Atlas, which they will probably open source at some point. Hopefully, it's a big project, and I'm not sure that will come out right away. But there's other, it's pretty easy to take that, and maybe you want to write kind of an accumulator and a pusher that will push to Nagios or any of the other kind of popular monitoring systems or alerting systems. So that's a nice way to get that data out of your Java application. And then SDAnix here, I popped in here for an example. That's the Cassandra client library for Java. Very nice to use if you're talking to Cassandra. Oh, and that's the end of my talk. This used to say Netflix jobs, but now it says Riot Games careers. So we are hiring too, and I'm doing a bunch of cloud stuff. A number of teams at Riot are doing cloud things. So if you're interested in moving to LA or telecommuting like me, give us a call. Well, thank you.